IGCSE Physics. Our topic today is gas pressure and volume. So to begin the lesson with, let us define pressure. So pressure is a physical force which is exerted on an object. A physical force exerted on an object. Whereas volume is a derived quantity expressing a three-dimensional extent. Remember, volume is expressed, the unit of measurement is cubic centimeters or cubic meters. So the cubic part represents or denotes three-dimensional. That is why volume is in cubic centimeters or cubic meters. All right. So if we take a certain measurement of gas and we close it in a container is measured in cubic centimeters. So the gas that we would have closed in that container will exert a force to the walls of the container. So the force that is exerted by the gas particles on the walls of the container is pressure. It is gas pressure. So I have two diagrams here, and as we can see, there is gas that is contained in this container. And I have put a measurement there of 4 centimeters, the length. And the gas is now compressed. And then we can see now that the particles are more concentrated in a tiny space than the first one. So obviously in the second diagram, there is higher pressure in the container. So let's look at the reasons why there is going to be a higher pressure in the second diagram. So the reason why there is higher pressure in the second diagram is because there is a lot of particles that are more concentrated per unit area than in the first scenario. In the first scenario, the space was 4 centimeters. And the particles of gas were much spaced. Now the volume has been halved, and now the particles, the gas particles, they are now occupying less space. So what causes pressure? So what causes pressure is that the gas particles, they collide with each other inside the container. So the collisions against each other that the gas particles make creates a force that pushes outwards of the container. Now, when you lessen the volume of the container, you cause more collisions. If you lessen the volume of the container by half, like in this scenario, the gas particles will also collide with each other more because there is less space that they are occupying. So, in other words, there is a constant behavior, or there is a constant relationship that exists between pressure and volume. So we can safely say pressure is expressed in pascals, whereas, so this is pressure, it's expressed in pascals, whereas volume is expressed in cubic meters, right? So we can safely say there is a constant, or there is a straight line behavior between pressure and volume. So we can actually come up with an equation that pressure multiplied by volume is equals to constant. Pressure multiplied by volume is equals to constant. That is the equation that we can safely draw. And this takes us to the Boyle's law, which states that for a fixed mass of gas at a constant temperature, the pressure is inversely proportional to the volume. That is Boyle's law, right? But what we have to take note, or what is important in this law, is the fact that the temperature should be kept constant for us to safely conclude that pressure times volume is equals to a constant behavior. Why does the temperature need to be kept constant? The temperature needs to be kept constant because when you reduce the volume which a gas is contained, there is increased collision between the gas particles and the temperature will rise. The rising of the temperature is likely to give you a false reading of pressure because the hot particles of gas will give you a higher pressure. So that means that when you reduce the volume of the container where gas is contained, you must wait for temperatures to fall to normal so that you can get the accurate reading of the pressure. So that has to be taken note of. Therefore, when we are talking about the Boyle's law, we have got what we call ideal gases. So ideal gases are gases with less forces of attraction between them. They are gases with less water vapor. Actually, they are gases without water vapor inside, because if gases are going to have high forces of attraction, then this law falls off because we are not going to get accurate readings. So the gases that we attach, or the gases that we can relate to this law, are ideal gases. At a later stage, we are going to get to teach each other what are these ideal gases. Okay, now that we have come up with an equation that pressure multiplied by volume gives us a constant behavior. And we have seen here that when we reduce the volume where gas is contained, the pressure is increased, which correlates to Boyle's law. Fine. So what we must further understand is that the relationship between pressure and volume is inversely proportional. In other words, when we reduce the volume, we increase the pressure. And when we increase the pressure, we reduce the volume. So, if we are given a scenario where pressure is 400,000 pascals, and this 400,000 pascals is contained in a space of 2 cubic meters. So let us calculate what will be the pressure if the container has been increased to 6 cubic meters. Okay, so this is the calculation that we must make. Pressure of 400,000 pascals was being contained in a space of 2 cubic meters. The same pressure now is being contained in a space of 6 cubic meters. So what is the pressure now? So let's go back to our law. Our law states that when we increase the volume, we decrease the pressure. When we decrease the volume, we increase the pressure. So in this scenario, we can tell that the volume has been increased. So the pressure should decrease. So the volume has been increased by 2/3 because it was contained in 2 cubic meters. Now it's in 6 cubic meters. So pause the video, go ahead and make the calculation and see what you come up with. All right, carrying on with the lesson, we must understand that the kinetic theory also talks a lot on the temperature, and I've explained to you that temperature plays a very important role. So there is a relationship between pressure, volume, and temperature. And changing one of them effects a change on the others. For example, if you have been containing 400,000 pascals of pressure in a 3 cubic meters container, if you increase the container, you are going to decrease the pressure. So there are going to be less collisions of gas particles. Therefore, the temperature will also fall due to the fact that there are less collisions in the container. On the same note, if you increase the pressure by decreasing the container, the cubic meters of the container, the temperature will change. It will rise because of increased collisions between our gas particles. So the three, volume, pressure, and temperature, they affect each other. A change in one will affect a change in the other two.